Okay, so Nathan Benbow, Engineering Design Manager at ASH these days, Australian Sustainable Hardwoods. People might know me from my VizTech days prior. So yeah, about 10 years consulting experience through VizTech and made the move across to ASH into the manufacturing space.
All right, and over to you, Danny, for an introduction.
Yeah, so working as a structural engineer at ASH, but previously about 8 years of experience in timber manufacturing and prefabrication. So that's probably more my background is the manufacturing base, Matt. So a lot of the drafting, carpentry, and sort of CNC machining.
Fantastic. All right, we'll kick it off with just the question. So for those unfamiliar with the procurement or working with the supply chain for mass timber buildings, how does ASH specifically approach the design and construction of timber buildings?
I might just jump in first. So I guess focusing on our mass slam glue laminated timber products specifically, we have an in-house design team. So Danny and I are two members from that team, and we provide specialist design support effectively on projects. So, and DfMA plays a huge role in that because we need to focus on throughput, which means we need to optimize design such that mass slam is efficient to press, first of all, and then also efficient to CNC machine. So our team will work closely with our production team to continually improve, I guess, the way that we design and manufacture our mass slam. I guess just to expand a little bit from a DfMA perspective, I guess material efficiency, first of all, but I'll go into a bit more detail there, but I guess taking fibre out where we can, which we can do with our hardwood that we use. There's sort of enhanced properties there, so we can take fibre out of projects, which will help with head height, surface reticulation, that sort of thing, but also just reducing volume, therefore reducing cost as well as any architectural benefits or, like I say, any other sort of implications with other building elements. But I guess I'll just add there, can be a bit of a fallacy in general too. Material sort of efficiency, you don't want to take that to the nth degree because you start to undo all of the sort of principles of DfMA by doing that. If you vary things too much, you add more risk, more complexity to a job, and that'll result in sort of cost and time. So standardization is really important. So you want to have, standardized parts. You want to limit the number of parts, therefore limit the number of sort of drawings and sort of machine files, which flows onto your quality control. So you've got the same sort of thing being done time and time again. So you're not missing any sort of nuances if everything is a repeatable part. So that's really crucial. That flows into connections as well, standardizing those. And if we talk about steel, if you're using, say, 12 mil plate everywhere, don't go and put just one 10 mil in, just keep it 12 mil. They're usually cut out of flat bar or plate, if they're laser cut or plasma cut out of plate, and they'll have to use something different. So that's just going to add cost, and once again, risk, which can flow into sort of time and cost impacts. Same with fixings, minimizing the number of fixings that you specify, the number of, say, lengths and types of screws, for example. You don't want to just have 20 mil increments across the job because that's exactly what you need from a theoretical design perspective. You want to sort of have an envelope of those and put them into discrete sort of sizes that capture everything. So you've got as few parts on a project as possible while achieving, all of your design requirements and aesthetic requirements too from an architectural perspective. And then I guess that leads into CNC as well, which is linked with your connections. You want to sort of optimize that. So if you're taking complexity out of connection design, then you're getting you'll reduce the amount of CNC machining requirements, which then, increases your throughput and mitigates delays or risk of delays and delivery, and also enhances assembly. If you're taking complexity out and you've got that standardization, that flows through to the assembly on site. anything you want to add in there, Danny?
Yeah, I mean, that's pretty much bang on. It's about the keeping it simple, really. So best thing you can do for cam file and the prefabrication is to keep it modular, keep it all the same. So, I mean, the analogy I use sometimes for a lot of these buildings is it feels a bit like a giant piece of IKEA furniture. There's slot A into slot B. And if you open up a bag with 6,000 bolts where you have no idea what's going on, it's going to freak out whoever the installer is. So keeping it simple, keeping it modular applies across the whole process rather than having hundreds of different parts where that could perhaps be standardized. Just helps along that process, both at our ends and at the installing end and the reviewing end. So it all comes together.
One of the things on projects is like both of you have got a lot of value to add on projects, and you might come in when the supplier's engaged. How does sort of this information flow to the very start of projects, particularly when you got the structural designer or the lead engineer on a project and the quantity surveyor, and all the best designs might not be going to the very start. So how can we? What are your thoughts on that?
Yeah, it's always a bit of a tricky thing or hard for everyone to adopt. I mean, it's been talked to death, effectively, the idea of ECIs and things like that, but it is important to change the mindset to actually have a successful mass timber project. You need to change the way you think about project delivery, project procurement, and getting us involved as early as possible, setting yourself up on the right path so that there's as few changes as possible. Because what tends to happen is it's kind of, coast along, hasn't quite landed, and then it's rush to get it actually designed specifically for a supplier. And, that process is really squashed, which is where you just add lots of risks to things. Things get missed. Things have to be adopted on site where they shouldn't have to be. The idea is that you have it all designed. It's all, LOD 400, 500, whatever, and millimeter perfect, and it goes together without a hitch. So the earlier that you get in touch, the better. And our team is here to support project teams through that. We don't expect anyone to have an intimate knowledge of our manufacturing capabilities or processes, and that's why we would prefer to be involved. And where all we'll be doing is assisting you and providing our experience. So,
just add to it as well that I mean, essentially working with that. I know the EOIs don't always work, but that early detection and that early work has minimal cost impact really there because you're working in the model. So we're modeling every single screw, dowel, plug, all the rest of it, and the impact to making changes and doing clash detection with mechanical services or steel trades or concrete trades or CLT suppliers only has the impact of moving things around, not someone physically having to crane that out of the way and put in screws because it hasn't been prefabricated.
Who do you reckon?
Sorry,
you go, mate.
No, I was just going to quickly add to touch on, I guess, the quantity surveyor component of that question in a way. So that's once again, I mean, we talk to quantity surveyors all the time. We're in the best position to provide sort of that assessment of our material. We will do that. It's a free service effectively through quoting, tendering stages, and we do that accurately. We have to anyway, ultimately. So we're in the best position rather than having those contingencies put in at that early stage that risk a mass timber project not, going ahead and it going to conventional steel and concrete because there's sort of unknowns and a lack of confidence there because they might not have done that type of project specifically or got enough experience yet. That's where they can once again come to us for, accurate information and data on that.
And I guess the terms for the highest, most accurate information would be the higher levels of, level of detail in terms of the information modeling. Who do you think should be doing the modeling and who should be responsible for getting it up to the highest level? Because you may have multiple mass timber suppliers on the one project, and some structural engineering firms out there think they're the ones doing the modelling. So what do you think the best way is here? And do you think it's sort of an unresolved thing out there in the industry?
You go first, Danny. We'll see if we both agree.
Sure. Yeah. Well, there's probably a couple of pieces in that. Look, I mean, the industry is getting better, I think, particularly in the mass timber space, of using models. We're going slowly from 2D format to 3D format. Where it probably trips up a little bit is the approval process. At the end of the day, it's great that everyone is using BIM and that it can be used for great things like clash detection and construction sequence, but at the end of the day, it's still being approved by 2D, so there is still an element in there as well too. In terms of who's doing that detailed modeling, it is great when the consultants are doing that early stages, and we'd probably split that apart in a couple of different levels with the different LODs. So locking off things like geometry first so that everyone's happy with the set out, sizing, all the rest of it, including any penetrations, before moving into things like connections, where it does hit that sort of LOD 400, where it is ready for CNC fabrication. So it's probably best done by the supplier. In terms of linking that with a CLT supplier in the one job, I think that that's been done pretty successfully, either by taken by one party or split into two with clash detection. That's a pretty straightforward thing to do, given that that's often split into two parts with sort of a post and beam GLT solution and then a flooring on top, whether that be a CLT or an ATC.
Yeah, I totally agree. I think taking it up to sort of the initial massing with the architects and structural engineer, I would suggest only really needs to get the intent across, sizing, that sort of stuff that might be able to be taken out of the model. Wouldn't expect them to then set things out accurately, detail connections accurately. That's certainly best done by us because it factors in with all of our machining capabilities too that we need to consider with that. So I think having that sort of line in the sand at design intent for structural engineers, architects, I guess that's up to them whether they want to actually produce a model that can be relied upon for set out would be that question, unless they would prefer that done in plan with an elevation for set out purposes, RLs and everything. But suppliers, I think, definitely would prefer to do it. We certainly would. It's far easier for us to control that too and to drive that forward, and we can work on that and share information to get feedback more quickly and progress the design that way. And then in terms of multiple suppliers on a job, I think it just comes down to clear designation of scope. So if you can just say this connection, this element, that's your scope, then it's easy to actually coordinate those. I think that works better. Well, that would be my preference rather than having one supplier do the entire model. Once again, purely because we can then put information in that suits our manufacturing processes better.
Awesome. Can you tell us a little bit about new products that might be in the pipeline or innovations in general, and to really move the product mix better going forward, and what benefits it might have for projects?
So Ash is developing sort of our first iteration of what we call Advanced Timber Composite, so ATC, our range there, and this is a mass slam and concrete composite floor system. So it'll be delivered as pre-assembled cassettes to site, ready for the pouring of the topping slab. And I guess the reason we're looking into this is to achieve sort of grids and spans that you'd see in conventional concrete and steel structures, you sort of 9x9, and hence mitigate the need for transfer structures, which are very costly and can sometimes, mean that the project falls over and goes just a conventional concrete route because of that. So it also means that we will have a DTS fire resistance in a way that allows us to express the soffit of the timber. And this, the system sort of is an improvement on the efficiency for the use of the fibre compared to some of the other ones available in the market. So sort of lots of advantages there. Also from a durability perspective, which is always a bit of a challenge with sort of pure timber structures or components of buildings. This idea of hybrid has a lot of merit. So this being a hybrid solution, and with that concrete topping, will probably streamline the ability to almost tank a deck and prevent sort of water during construction. So that's just a bit of another advantage there. Something else we're doing, we're launching a new hardwood timber species in plantation oak. So over the next 10 years, there is a decent sort of estate reaching maturity required to produce quality timber. So it's taken a lot of work to develop and learn about that species, but we've managed to sort of develop the right cutting pattern from the log and drying techniques, which means we're able to actually use it in mass slam as well as some other existing appearance grade applications, so windows and architectural joinery and that sort of thing. While I say that too, Ash sort of controls or takes everything from, we're a sawmill into a dry mill and then 9 separate manufacturing lines. So we're by far Australia's largest hardwood manufacturer. So we're not just sort of a timber mill and then, obviously with the mass slam stuff, but we've got a large range. And I guess the design for manufacture component of that acronym, we take that right from the log. So at the sawmill, where we're actually, designing the cutting patterns, because we're our own biggest client, we actually produce feedstock to go into other products ultimately. So we're not selling that to market. We're using it to produce other products down the line. So we need to set ourselves up to really, optimize everything through every process to get the best result at the end of the day. And sorry, just one more, Danny, jump in a sec. We're commissioning Australia's only pre-finished engineered flooring plant. So and we expect that to be finished mid this year. So that's really exciting too.
Yeah, awesome. You got anything to add there, Tony?
Pretty much covered it, I reckon there. I think, just hinting on that, how many different manufacturing plants there are, it just also enables us to get the most out of the log as well too. So there's minimal wastage. So whatever can't be used for mass slam is used for something else, and it separates sort of high grade or what would be seen as low grade and potentially chipped or used as waste, always finds a home somewhere.
And one of the complexities on some projects is having multiple suppliers on one. And I guess, with this new product range, you could probably have the floor system, secondary floor system, and a primary system supplied under one roof, and shop drawings, and just reduces some of the complexities there, I'd imagine, if you want to dig down on that one a bit.
It really does. And, thinking of some, projects we're doing currently, you get certain feedback, and some of the feedback is, we're delivering. And then just that idea that if we could deliver the whole sort of structure and, take all of that on, and then, the client, whether it's the contractor or the developer, is dealing just directly with us for the whole thing. I guess that always works well when you've only sort of got that one party to deal with and coordinate. We'd be doing all of that and factoring in the whole process. So I think that certainly would streamline things from that perspective too.
And that relates as well to, all the other manufacturing plants as well. So if there's a need for a matching cladding, a matching flooring, or for the ATC, perhaps that's a soffit with space buttons as well. It can all match the same material, and it can all come from the same supplier. So there's no issues about how that integrates.
Yeah, awesome. So going forward, maybe just a bit of an open-ended question for you both. What are some of the key challenges you're seeing on projects? And it's probably the whole question around this is probably evolving, and I've probably asked you this 3 times now, Nathan, that you've been on the podcast. But yeah, what are the key challenges that need to be addressed that you think should be prioritized at the beginning of a project?
So, I mean, I'd put it down to sort of, we just mentioned sort of grades and member sizes initially, getting that right from the start, just to set things up correctly. Now, I know that, you've got to go out to tender. So you can only really specify one grade, but at least gearing up so that you can change things over, or just relying on us to do that. I guess that's a bit of a challenge. We just see in the past have seen, some specifications that you can't actually get, whether it's trying to specify our products or sizes or someone else's, and they're specifications that don't actually, exist readily in the market. So you're sort of just setting yourself up for failure there. But so that'd be one challenge, sort of getting over that initial hurdle. And it almost gets put on us for some reason. It feels like it's like, oh, why can't you do that? It's specified that way. You should be able to just give us what we want, rather than, okay, this is available. We need to get it right in the specification. And then I guess the general, other challenges are what always comes down to, I guess, cost and time. They're the real linchpins in adopting mass timber to start with. So yeah, to overcome those challenges, it's probably more just being given the appropriate amount of time to develop a true sort of mass timber solution, rather than, we've spoken about it many times, but things getting converted from what was, say, a concrete building design and then just wanting to substitute in mass timber. You're sort of set up for a building that you're not really, suiting the properties of the material, so to speak, or you're not capturing the building sort of arrangement that best suits the material. So once again, you're trying to sort of fit a square plug in a round hole type thing. So actually committing to that, and even if that means you're having to run parallel designs, if there's risks outside of the actual structure and the delivery of the structural components, then that might have to be done in the background. But I guess on that point, because we control everything from, log to finished product, there's no real risk. That risk can be, turned into certainty from us. If there's a commitment there to use us as a supplier, there's guaranteed resource. If we provide a production slot and that's booked in, provided on the client side and the project team side, all of the milestones in the design lead-in and everything, as long as they're met, we will guarantee that we will manufacture and deliver according to program.
Danny, how about you? Oh, you go, Nathan. You still going?
No, I was just going to say,
Sorry.
Danny, jump in.
Yeah, and as Nathan's mentioned, it has come a long way in probably even the last 6 or 7 years. I look at what timber buildings were being done as, which is exactly as Nathan's suggested, of a concrete building where they thought, oh, maybe we'll have a crack at timber, and done a quick convert on stiffness, and it's not really worked out, and then potentially questioned why it didn't work out as well too. Whereas now we're seeing lots of timber buildings as, consultants and clients become more familiar from what's happening in Europe and North America, but also in Australia too. Everyone has generally seen a timber building. They've got up close to it, like touch and feel the columns, and it's a different feel inside as well too. So I think that early development sort of drives the consultants to design it specifically for timber rather than, say, convert it, which is a good thing. Still a long way to go. I think there's challenges around things like, as mentioned, structural design, but also fire as well, with how that works and how that impacts projects. But I think with the extensive fire testing that's been done and the size of some of the projects that are coming through, then I think it's a physical thing that you can see the example of, rather than, say, relying on a theoretical example of it, which I think's helped a lot.
Yeah, the other thing too, I mean, it has really improved too in recent years. There's a lot more experience now, and consultants upskilling in areas and all of that. There's more and more confidence in it. The other challenge though is, rather than dipping your toes in, fully diving in, committing to the material, committing to collaboration, and like I mentioned earlier, changing the mindset of how you tackle the project, getting all of that work done up front. Fortunately, on a couple of projects recently, we've had some of the best experience of our respective careers to date, with that actually happening, everyone buying into it and lots of collaboration. And we're seeing sort of the advantages of that through construction now because of it. So when it's tackled in the right way, you can actually achieve, I guess, all the things that everyone's been talking about over the years. The idea of speed of construction, enhancement, those sorts of things, and reduce costs and stuff. Sadly, on most jobs, it hasn't fully been realised or hasn't been realised at all, and that's generally because it's purely been a substitution of material rather than a commitment to mass timber.
All right. Well, I think that's a phenomenal one to end it on as well. So if people want to find out more about yourselves or what we've been speaking about now, ATC, if you got a project in mind, where should we be pointing the audience?
They can come directly to us if they've already got our contact details, or they can track them down. Otherwise, our website has all that information and you can reach out there. Our team's here to help. So.
Fantastic. Well, thanks so much for coming on the podcast, Nathan and Danny. That was awesome.